outreach with New Jersey Audubon, coming to you once again from my front yard. So today we're going to continue our discussion about tapping nature's nutrients. In other words, how do plants get the nutrients they need from the ground? So in our last video we talked about nutrients nitrogen, phosphorus, and potassium. So today I'm going to show you how to do testing on your soil to figure out how much of each nutrient you have. So before you even begin to plant a garden, you need to plan your garden. And in planning, you take a chemical test because you need to see if your soil has too much or too little of certain nutrients that your plants grow nice and healthy. Now, you also want to test your soil so that you don't waste time and money and you're being kind to the environment. So the time and money part is simple. Why buy chemicals and fertilizer that you don't need? That's just wasteful. But in addition, if you're applying fertilizers that your garden doesn't need, all it does is wash into our water system after a heavy rain. So that can affect water quality in a lake or pond or stream downstream from where you live. So for more information on how fertilizers and pesticides can affect water quality, please see our water chemistry video. So today I'm going to walk you through the process. We're going to learn how to take our soil sample, and then I'm going to show you a little bit about how the tests work and see what levels my garden soil gets. So as you can see behind me, this is my part of my front garden. It has some bergamot, it has some ferns, and it has some little bluegrass growing in there. But I really want to expand my garden out in the front and make it a little bigger to include more plants for pollinators and honestly make less grass for me to mow. So I'm going to show you a very simple map of where I would like to expand my garden, and then we will talk briefly about how to take a soil sample and then go through those tests and see what they say. So let's get started. So as you can see here, this is the top view of my house, and the white rectangle in the front is my existing garden. So it's very long and skinny, not very large at all. And the yellow here in this photo shows where I would like to expand my garden. So when I talk about taking my composite soil sample, this is where I've taken my sample from. Okay, scientists, so here you can see that I sifted my soil sample. Now again, we take a composite soil sample. So what that means is within the area of the garden that I showed you on the map that I want to create, I took 5 soil samples from about 6 inches deep, put them all into one container. I let that sample dry out for a couple days, and then I just put it in a dollar store sifter, sifted out all the big chunks, and now we have a clean soil sample that we can work with. So before we get started, I like to put on my rubber gloves. If you don't wear glasses, put on your goggles. I've got my test tubes all set up. I've got my test kit here set up. I've got a timer on my watch, and I have my data sheet. So you can see I filled out the top of my data sheet like I always do. Today is the 5th of May, 2020. I live in the Rahway River watershed in West Orange, New Jersey. It is 13 degrees Celsius outside. Latitude and longitude, I used Google Maps to find that. And as of today, there was no precipitation within 24 hours. However, if you are really looking for a detailed analysis of your soil sample, you may want to record the precipitation from the evening before you take your soil sample. And then here are the reagents that we're going to test today on the top. And if you followed any of Emily's videos on the other characteristics of soil and are going for a schoolyard habitat pathway through eco schools, you have other things here, and then there's a whole other side to this worksheet which I will post with teacher resources. If you're just doing this for your own garden, you can really just worry about this top piece for now. Okay, so now that we're set up for the test, we've got our gloves on, glasses on. and I've got all my materials ready. Let me just explain the basic way that each of the tests gets done. So there's little differences for each one, but basically what is happening is each test has some sort of reagent that reacts with the soil. So we put the reagent in, we put the soil in, and we have to mix. And what happens there is, just like from our Tapping Nature's Nutrients video 1, the nutrients that are in the soil that we're trying to discover react with the chemical that is put in with the soil, and it's released into the liquid. And then usually we are comparing a color of the liquid that's on top of our soil sample with a chart, and that will tell us the result for each test. So then we will compare our results on our chart, and we'll talk about what that means. So I'm going to start with pH, and then we're just going to go through each test, and I will explain why each test is important as we go through them. So let's begin with pH. And now, as you can see, our sample is really mixed up, so we just have to let that settle so that we can read the result. Okay, so our pH test is ready and kind of looks like this. And when I hold it up in the sun and compare, it looks purple to me. So I'm going to mark it as an 8. All right, so our next test is phosphorus, and it's pretty much the same procedure. Different indicator, different amount of soil, but similar process. Okay, so now this again is all mixed up. We just have to let it settle to the bottom. Okay, so the phosphorus sample has settled to the bottom. You can see it's clear on top. So now we need to deal just with the liquid on top. So we're going to extract that liquid and add our other reagents here, and we should get a result shortly. Okay, so our tablet has dissolved. So let's compare our test. And to me, it looks like a little more than a trace, I don't know, between a trace and low or low. So I will record that on my sheet and we'll talk about it in a minute. Okay, our next test is nitrogen, so here we go. Okay, so now we just have to let it settle. Now that our nitrogen sample has had time to settle, we're going to extract the liquid off the top, add a little more reagent, and we'll get our result in about 5 minutes. Okay, so our nitrogen sample has sat for 5 minutes, so now we can compare the color. And to me, this looks like there's pretty much no pink tone at all. So I would say even less than a trace. There's hardly any nitrogen in my soil. Okay, so our next test is for potassium, which is also known as potash. For this test, I actually make 2 samples. It's just easier than repeating myself again. And it's basically the same process. So I'm going to start adding my reagents. Okay, now we let these settle. Okay, now that our potassium samples have settled and there's clear liquid on top, I'm going to take the liquid off the top of them, transfer it to the other test tube, and continue adding reagents. So the last step of the potassium test is really kind of fun. So here we have our purple liquid, but now we have one more reagent to add. And we do this a couple drops at a time. And when our liquid turns from purple to a turquoise color, that's how we get our result. So anything less than 8 drops means that there's very high amounts of potassium in the soil. So I'm going to go ahead and add 8 drops to start. And that way we know if it's lower than that, we can keep going. 1, 2, 3, 4, 5, 6, 7, 8. So we've added our 8 drops. I don't know if you can see it, but the very top is turquoise. But when I mix it, does it stay turquoise? Let's see. Still kind of purple. So let's add 2 drops and see if we get it to change to turquoise. So that was 8. This is 10. 9, 10. Let's see if it changes. It still looks purple to me. 11, 12. Now here's our comparison. It still looks purple. $13, $14. Ah, there we go. Now it's turned turquoise color. It's no longer purple. So that is 14 drops to get the change we need, and we'll record it on our chart. Okay, so as you can see, I have recorded all of my data on my sheet, and let's just talk briefly about what each result means. So my soil pH of 8. So pH is the measure of how acidic or alkaline something is, or basic. So acidic would be like lemon juice, alkaline or basic would be like soap. So our soil was at a pH of 8, which is a little more basic than neutral. So neutral would be a 7. So 8 is more basic than that. So based just on my pH of the soil, I may be limited to a certain class of plants that I could plant in my garden. Our next result is for phosphorus. So phosphorus is important for young plants because they absorb large amounts of phosphorus, which speeds up seedling development and promotes early root formation, which early strong roots means stronger adult plants. So it's really important to have strong root development. So our result was low, close to kind of a trace. It was in between the two of them. So depending what plants I want to plant, I may have to amend my soil and add a little more phosphorus in order to encourage that root growth. The next test result is for nitrogen, which I circled trace, but it was really at none, which isn't very unusual for a lot of soils to have very little nitrogen. A lot of fertilizers have nitrogen in them for that purpose. And nitrogen is very important because it's in every living cell. And it's directly involved in photosynthesis, which if you watched our Tapping Nature's Nutrients video, you understand that that is how plants make sugar from sunlight reacting with carbon dioxide and water inside the plant. So nitrogen gives plants rich green color. So there are plants that can fix nitrogen back into the soil, meaning they give nitrogen into the soil, things like clover. And then there are other plants like corn, which suck nitrogen out of the soil. So you just have to know what you're planting in order to know if you need to put nitrogen in your soil or not. And then our last result was for potassium or potash. So we were at a medium, maybe a medium low. I kind of re-looked at our results. And potassium or potash acts as a catalyst. So a catalyst is something that, think of it as like a helper. It helps other chemical processes in the plant. And so adding potassium to your soil is kind of like a general tonic for plants. It just strengthens everything about the plant, helps plants resist disease and extremes of weather. So we will look at a chart momentarily and compare our results with the plants that I want to plant and see how I will have to amend my soil.
Okay, so here is a guide from the soil testing kit that tells us which plants prefer which kind of pH. And so as we can see here, group B plants prefer moderately acidic soils. So our soil was at a pH of 8. So as it stands now, anything in this group we would have to amend the soil to include. And that's good to know because I would actually like to include Coreopsis, which is in the aster family, and maybe a couple azaleas. And I actually would like holly to kind of screen that front window a little bit. So I may have to add something to lower the pH of my soil if I want to grow those things in the front. Now mostly over here in the group A plants, they're mostly vegetables. However, there are a couple things in here like parsley, which is excellent for pollinators. And there's sage, which is also great for pollinators. Red bud trees are beautiful. I'd like to add a red bud, would be a great idea because I'm actually taking out a plum tree. So you get the idea. You kind of just have to look at where your soils are pH-wise. And for some areas, wherever I want to plant the azaleas and holly and Coreopsis, I may have to amend those areas slightly so that my plants have the best chance of growth. Not saying they won't grow in a soil with a pH of 8, but that this gives them their more preferred habitat. And then for the other plants that I want to add, it looks like a pH of 8 will be okay for those. So I may not have to amend my whole garden just where I want to put these plants over here. Okay, so here's another chart that is included with the soil test kit. and its relative nitrogen, phosphorus, and potassium requirements for common crops and plants. So most of the time we care about how much macronutrients our plants are sucking up into their body because we are eventually going to eat those plants and need those nutrients as well. So most of this here is for food crops, right? We've got cabbage and carrots, things like that. However, over here we do have deciduous plants, deciduous shrubs, deciduous trees, and evergreen plants, evergreen trees, annual flowers, and perennial flowers and bulbs. And then we've got some grasses and things that I'm not interested in. And really that's it. So we notice here for deciduous plants and trees and shrubs, we've got, medium nitrogen. They don't need a lot of phosphorus. They don't need a lot of potassium, which is good for us because I didn't have a whole lot of either one of those. The shrubs, again, medium nitrogen, medium phosphorus, low potassium, and the same. Now that means that here I may need to amend for my nitrogen because I had no nitrogen at all. So these parameters here might be okay, but I had nothing. So I'm going to have to add some nitrogen. So get a fertilizer for that. Now here, for evergreen plants, it's all, everything, they pretty much grow anywhere, right? Evergreen trees, same kind of thing, okay? However, if I want to plant annual flowers, meaning go to the garden center now, get those flowers and plant them every year, I am going to need a lot of fertilizer in that front area because I am not anywhere near for any of these. So I may actually skip the annuals, except for some herbs, and stay more with my perennial flowers and bulbs, which is what I would tend to do because I don't like to plant things every year. So I'm still going to have to amend the soil, but I'm not going to have to get it as high as here if I want to add annual flowers. So again, going back to the beginning of the video, that's important to realize because why am I going to waste money buying more fertilizer or a more potent fertilizer that I don't need if I'm not going to plant annual flowers anyway? So I can get away with lower concentrations using less fertilizer because I'm choosing plants that don't require a lot. Now, if you like annual flowers, that's fine. Just know that you're going to need a certain kind of fertilizer to get those plants to really grow.
Okay, so now that we're done with our tests, we always have to clean up. So with any chemical testing in the field, I have a clearly labeled poison bottle, a P on the cap, labeled poison here, and I will dump all of my chemical tests into the poison bottle and dispose of it properly. You never ever want to dump your reagents in the field because you could harm wildlife. So make sure that you follow the directions on your kit of how to properly dispose of your reagents.